Hello friends, welcome back to my YouTube channel. In today's video lecture, I will be discussing a numerical. The numerical is based on the application of Langmuir Adsorption Isotherm for finding out the surface area of any adsorbent. So this is numerical number 1, and in my next video, I will be discussing another numerical. That will be based on the Brunner-Emmett-Taylor adsorption isotherm, BET adsorption isotherm. This numerical is based on the application of Langmuir adsorption isotherm. So this is part number 9 of my discussion on adsorption. I have completed my discussion on various adsorption isotherms. I am giving link to the playlist which has all my videos on adsorption. If you have not yet seen those videos, you please watch them. So let us proceed. To begin with, we will look at the numerical statement. Spherical particles of 50 nanometer diameter and density 2290 kg per meter cube are pressed together to form a pellet. And the following equilibrium data was obtained for the adsorption of nitrogen at 77 Kelvin. So the equilibrium data is given to us. I'll come back to this. In this case, Pn2 is the partial pressure of nitrogen in the gas phase, and Pn2 naught is its vapor pressure at 77 Kelvin. The density of liquid nitrogen at 77 Kelvin is 808 kg per meter cube, and the area occupied by one adsorbed N2 molecule is 0.162 nanometer square. The Avogadro number is 6.02 into 10 to the power 26 molecules per kilomole. So with this data, we are supposed to find out the surface area of the pellet by using Langmuir adsorption isotherm. So what is given to us? An adsorbent pellet is formed. It is formed from spherical particles. Individual spherical particle has a diameter of 15 nanometer and it has a density of 2290 kg per meter cube. So such spherical particles, they are pressed together to get the adsorbent pellet. Then equilibrium data, it was obtained for the adsorption of nitrogen at 77 Kelvin. So the data has two parameters in it that are in equilibrium with each other. One is Pn2 by Pn2 naught. Pn2 is partial pressure of N2 in the gas phase, and Pn2 naught is vapor pressure of nitrogen at the prevailing temperature, which is 77 Kelvin. The density of liquid nitrogen, one parameter is ratio of partial pressure to vapor pressure of nitrogen, whereas the other parameter is meter cube of nitrogen per kg solid, per kg adsorbent into 10 to the power 6. So meter cube nitrogen per kg solid into 10 to the power 6 is equal to 66.7. So I will explain this when I come to this during the solution. Then the density of liquid nitrogen is given to us. Then the density of liquid nitrogen at 77 Kelvin is 808 kg per meter cube. And after nitrogen molecules go on the surface of adsorbent, then each nitrogen molecule is going to occupy an area of 0.162 nanometer square. The Avogadro number is given to us. It is 6.02 into 10 to the power 26 molecules per kilomole, and we are supposed to find out area of the pellet. So let us move ahead. First, we will note the data that is given to us. So given data is the adsorption task. What is the adsorption task? Adsorption of nitrogen at 77 Kelvin. The adsorbent pellet that is being used, it is to be formed from spherical particles, and for this spherical particles, what information is available with us? a diameter of individual particle is 15 nanometer. That is 15 into 10 to the power minus 9 meter. I'm converting it to meter. Then density of the particle it is given. It is 2290 kg per meter cube. So the task is to adsorb nitrogen from, let us say, air. Nitrogen from air by using an adsorbent pellet. And I have just told you how the adsorbent pellet is being formed. For liquid nitrogen, when nitrogen goes on the surface of the adsorbent, its density, I am denoting it as rho L. It is given to us. Rho L is 808 kg per meter cube, and AN2, which is nothing but area occupied by one nitrogen molecule on the surface of the adsorbent. So when the adsorbent, let us say this is the adsorbent, and when nitrogen molecule go on the surface of the adsorbent, then area occupied by this molecule is 0.162 nanometer square. This is given to us. Then Avogadro number is given. It is I will denote it by capital N. So capital N is 6.02 into 10 to the power 26 molecules per kilomole. The equilibrium data is given to us. So in the gas phase, you have partial pressure of N2, ratio of partial pressure of N2 to vapor pressure of N2 at the prevailing temperature. And on the surface of the adsorbent, the data, or we have meter cube of nitrogen per kg of solid into 10 to the power 6. So you have different values for meter cube of nitrogen adsorbed per kg of solid into 10 to the power 6, and we have different values for this ratio. This Pn2 by Pn2 naught is in equilibrium with this meter cube nitrogen per kg solid into 10 to the power 6. So the equilibrium data is given in this form. Then what to find? We are supposed to find out the surface area of the adsorbent pellet, and we will be using the Langmuir Adsorption Isotherm for getting the surface area of the pellet. So let us move ahead. So let us solve the numerical. We know the Langmuir Adsorption Isotherm, it is given by this equation. I have discussed derivation of this equation in my earlier video on Langmuir Adsorption Isotherm. Link is available. Link for the entire playlist is available in the description section. You please watch it. So the equation is P upon Cs is equal to Pa upon Csm plus 1 upon B1 into Cs. Now what are the terms involved in it? Cs is the concentration of the adsorbate, in this case nitrogen, on the surface of the adsorbate. Concentration can be expressed in many ways. So we are going to understand that. Then Csm is the concentration of the adsorbate, and that is nitrogen, on the surface of the adsorbent when the monolayer of adsorbate molecules is complete. So when the adsorbent surface, let us say you have the surface, let me just show you. So you have the adsorbent. And then nitrogen molecules are going to get adsorbed on the surface. So now if you look at this diagram, you can easily understand that the entire surface of the adsorbent has been occupied by the adsorbed molecules. So Csm represent concentration of the adsorbate, that is nitrogen, when this happens, when the monolayer is complete. Monolayer is complete on the surface of the adsorbent. That is Csm. So let me erase first. Then B1, it is a constant. Pa is partial pressure of A in the gas mixture. So in this case it is nitrogen. So it will be P of N2. So I have used this notation. Then if the concentration of the adsorbate on the adsorbent is expressed as volume of adsorbate per unit mass of adsorbent. That is, now we are talking about the concentration. Now, if you express concentration as meter cube of N2, that is adsorbate, per kg of adsorbent. So you can modify this equation. If you have to, or you can express concentration on the adsorbate in terms of this quantity, meter cube of nitrogen per kg of adsorbent. So if the concentration of the adsorbate on the adsorbent is expressed as volume of the adsorbate per unit mass of the adsorbent, then V will be, capital V will be the volume of adsorbate, which is nitrogen in this case, per unit mass of adsorbent, and Vm will be the volume of the adsorbate per unit mass of the adsorbent when the monolayer of the adsorbate molecule is complete. Just I talked about CSM. If you express the concentrations as a meter cube of nitrogen per kg, then corresponding to CSM, we will have Vm. So, what we are going to do, we are going to replace CS with V and CSM with Vm in order to use this equation in the present discussion. So, I hope you are understanding what we are going to do with the adsorption isotherm equation. So, let us move ahead. So, you have now, we will be modifying it as I said. So, it will be Pn2 by V. A is N2. So, Pn2 by V. CS we have replaced with V. Pa again it is Pn2, and CSM we are replacing with Vm, plus 1 upon B1, the constant will remain as it is, and CSM we are replacing with Vm. Now, we have expressed the Langmuir adsorption isotherm in terms of volume of adsorbate adsorbed per kg of adsorb. Let us move ahead. Now, further, in order to have the ratio, I want to have this ratio in this equation. Pn2 by Pn2 naught. Partial pressure of nitrogen divided by Weber pressure of nitrogen. So, in order to, for that I need to divide this equation. I need to divide this equation by Pn2 naught, Weber pressure of nitrogen. So, it will be Pn2 by V into 1 upon Pn2 naught, that is equal to Pn2 by Pm into 1 upon Pn2 naught plus 1 upon B1 into Vm into 1 upon Pn2 naught. I will rearrange it in a different way. So, it is Pn2 by Pn2 naught into 1 by V is equal to Pn2 upon Pn2 naught into 1 by V plus 1 upon B1 into Pn2 naught into 1 by Vm. Now, this term 1 upon B1 into Pn2 naught, it is constant because at constant temperature vapor pressure is not going to change. B1 is a constant. So, I will use a different letter to represent that constant. So, it is Pn2 upon Pn2 naught is into 1 by V is equal to Pn2 upon Pn2 naught into 1 upon Vm plus 1 upon B2 into 1 upon Vm. Now, I have used a different letter. In this case, V2 is Pa naught into B1. So, if you look at this equation, it is of the form Y is equal to Mx plus C. It is of the form, let me write it. It is of the form, I will write it over here and then I will erase it. So, Y is equal to Mx plus C. So, it is an equation of a straight line where if Y is plotted on Y-axis, X is plotted on X-axis, you will be getting a straight line, slope of this line will be M and then intercept will be C. So, this equation, the equation that we got, the modified form of the Langmuir adsorption isotherm, it is of this form. So, that means the plot that we have to use, it will be this plot. So, on the y-axis, you are going to plot Pn naught upon Pn2 naught into 1 by V. This is y. And then on the x-axis, you are going to plot Pn2 by Pn2 naught. So you'll be getting a straight line. Slope of this line will be 1 upon Vm. So by just knowing the slope of the line, you'll be able to get Vm. That's it. And from Vm, you can find out the surface area of the plate. Then intercept in this case is 1 upon B2 into 1 upon Vm. There is no need of finding the intercept. Even if slope is known to us, we can get the value of Vm. Ultimately, we have to get the value of Vm, which will then be converted to the surface area of the plate. So you'll be learning that. Let us move it. So the data is given to us. First, we will be plotting the graph. So you have this data. Now I have changed the table. So you have column for Pn2 upon Pn2 naught, and then column for meter cube nitrogen, meter cube N2 per kg solid into 10 to the power 6. And we are supposed to find out this graph. We are supposed to plot this graph. So we need to find out this quantity. Pn2 by Pn2 naught is directly no, but you have to get this value in order to plot the graph. So in this case, V, meter cube nitrogen, meter cube N2 per kg solid, that is nothing but V, volume, concentration. And into 10 to the power 6, this value for this entire quantity, values for this entire quantity are given to us. So for example, for the first value, V, that is meter cube nitrogen per kg solid into 10 to the power 6 is 66.67. That is V, meter cube nitrogen per kg solid is equal to 66.67 into 10 to the power minus 6. That means in the second column, you can get V. For getting V, you will have to multiply each entry with 10 to the power minus 6. That is what you have to understand. Very important thing. Okay. Then Pn2 by Pn2 naught into 1 by V. For first reading, it will be Pn2 by Pn2 naught is 0.1. So it is 0.1 upon V. For the first reading, it is 66.67 into 10 to the power minus 6. So it comes out to be 1499.25. So in this way, values for all other readings or all other values of this quantity Pn2 upon Pn2 naught into 1 by V, you can find out. So I'm directly taking all those values. I have told you how to get those values by taking the first reading into consideration. So let us move it. So in this way, I get all the values for Pn2 by Pn2 naught into 1 by V. And we will be now plotting a graph between Pn2 by Pn2 naught. It will be plotted on the x-axis, and Pn2 by Pn2 naught into 1 by V, it will be plotted on. Okay, now let us plot the graph. So we will be using this data. On the y-axis, we are going to plot this quantity Pn2 by Pn2 naught into 1 by V. And on the x-axis, we are going to plot Pn2 by Pn2 naught. So if you plot the given values, you are going to get a graph like this. Now, forget about the curve part of the graph. We will concentrate on the straight part of the graph. And I'm going to approximate the straight part by drawing a straight line, which corresponds or which coincides with the straight part of this graph. Then you have a curve afterwards, but let us in our discussion consider the straight part so that we can find out the slope of this line, and then the slope of the line can be used to find out the area of the adsorbent, surface area of the adsorbent. So we are considering the straight part of the graph in our discussions. So let us move ahead. In the next step, I will be finding out the slope of this line. Okay, now let us find out the slope of the straight line, slope of this straight line, geometrical slope. So for this, I will consider 2 points on the line. One is this point, which has coordinates of 0.2 and 2659.57. And this is the other point, which is having coordinates of 0.1 and 1499.25. So in this case, geometrical slope will be y2 minus y1 divided by x2 minus x1. That is, slope is equal to 2659.57 minus 1499.25 divided by 0.2 minus 0.1. That is, slope is equal to 1160.32 divided by 0.1. That is, slope is equal to 11603.2. And slope is nothing but, we know, as per Langmuir equation, slope is 1 upon Vm. So 1 upon Vm is equal to 11603.2. That is, Vm is equal to 1 upon 11603.2. That is, Vm is equal to 86.18 into 10 to the power minus 6. Now let us use this value, the value of Vm that we have got by plotting the Langmuir adsorption isotherm. Let us use it for getting the surface area of the adsorption. Let us move on. So we got Vm as 86.18 into 10 to the power minus 6, and unit is meter cube per kg. Volume of the adsorbate per unit mass of the adsorbent. Now this is Vm. What is this? This is the volume occupied by a monolayer of N2 molecules that covers the entire surface of 1 kg of adsorbent pellet. So if I show the adsorbent pellet, 1 kg of adsorbent pellet, then this volume will be occupied by the molecules of nitrogen, and these molecules will be covering the entire surface of the adsorbent. So this volume of this N2 molecules, which has occupied the entire surface, the monolayer of the adsorbed molecules have occupied the entire surface of the adsorbent, 1 kg of adsorbent. The meaning of Vm being 86.18 into 10 to the power minus 6 is this molecules has a volume of 86.18 into 10 to the power minus 6 meter cube on 1 kg of adsorbent. Okay. So now we are going to convert this Vm. Right now it is in meter cube per kg. Now I will be converting it to kg per kg. That is, I will be converting 86.18 into 10 to the power minus 6 meter cube of nitrogen into kg of nitrogen. So how can I do it? For that, density is given to me. Density is given to me. So density is what? Density, it is mass upon volume. So volume is known to us. Density is known to us, and we have to get mass. So it will be rho into V. So if I multiply this meter cube with density, I will be getting kg of N2. So let us later do that. First, let me erase it. So it will be Vm is equal to 86.18 into 10 to the power minus 6, and now I am multiplying with density of liquid nitrogen that is given to me or given to us. So when I do that, it will be kg per kg. So Vm will be equal to 86.18 into 10 to the power minus 6 into 908 density, which is given to us kg per kg. That is, Vm will be equal to 0.078 kg per kg. So now meter cube per kg, we have converted it to kg per kg. Next, I will be converting Vm to kilomole per kg. That is, kg of nitrogen will be converted to kilomole of nitrogen. So converting Vm to kilomole per kg. How are you going to do that? Simply by dividing with the molecular weight, because moles is mass upon molecular weight. So mass is, we have the mass 0.078 kg. If I divide it with the molecular weight of nitrogen, I'll be getting kilomole per kg. And molecular weight of nitrogen is 28. So Vm will be equal to 0.0078 divided by 28 kilomole per kg. That is, Vm will be equal to 0.00279 kilomole per kg. So in this way, meter cube per kg of nitrogen is now converted to kilomole per kg of nitrogen. So this many kilomole of nitrogen are adsorbed on 1 kg of adsorbent surface, and this covers the entire surface of the adsorbent, as I discussed just now. So I hope you are understanding the concept. If you have any doubt, you please let me know. Let us move ahead. So we got Vm now in kilomole per kg. Vm is 0.00279 kilomole per kg. That means the monolayer is containing 0.00279 kilomole of nitrogen per kg of adsorbent. So the monolayer has 0.00279 kilomole of nitrogen. Now let us convert Vm from kilomole per kg to number of N2 molecules per kg. Number of N2 molecules per kg. So for that, Avogadro number is given to us. It is 6.02 into 10 to the power 26 molecules per kilomole. What is the significance of this Avogadro number? 1 kilomole of nitrogen contains 6.02 into 10 to the power 26 molecules of nitrogen. So if 1 kilomole of nitrogen is containing this many molecules, how many molecules of nitrogen will be there in 0.00279 kilomole? The simple thing that we need to know. So the task is to find the number of N2 molecules in 0.00279 kilomole of N2 from this information. If 1 kilomole contains 6.02 into 10 to the power 26, how many N2 molecules will be there in 0.00279 kilomole of N2? Now let us move on. So we are converting Vm to number of N2 molecules per kg. So I have discussed this. Avogadro number is given to us, 6.02 into 10 to the power 26 molecules per kilomole. That means in 1 kilomole of nitrogen, there are 6.02 into 10 to the power 26 molecules of nitrogen. And now the task is to find out the number of N2 molecules in 0.00279 kilomole of nitrogen. So the equivalence will be written in this way. 1 kilomole of nitrogen is equivalent to 6.02 into 10 to the power 26 molecules of nitrogen. Therefore, 0.00279 kilomole of nitrogen is equivalent to how many molecules of N2? Let us say it is Y. We have to get Y. So I'll be doing cross multiplication. So 1 into Y is equal to 0.00279 into 6.02 into 10 to the power 26. So that is Y will be equal to 0.00279 into 6.02 into 10 to the power 26 divided by 1. So from this equivalence, we get this equation. 1 into Y is equal to 6.02 into 10 to the power 26 into 0.00279. And from this equation, you get Y. So this gives us Y as 1.68 into 10 to the power 23 molecules of N2. That means in 0.00279 kilomole of nitrogen, which is occupying the entire surface of the adsorbent, there are 1.68 into 10 to the power 24 molecules of nitrogen. That is 1.68 into 10 to the power 24 molecules of nitrogen occupies the entire surface of the adsorbent. And the surface occupied by one molecule is given to us in the numerical statement. So from this, we can easily find out the surface area that will be occupied by 1.68 into 10 to the power 24 molecules of nitrogen. And that surface area is the entire surface area of the adsorbent molecule, of the adsorbent. That means the area occupied by this many molecules of nitrogen is nothing but area of the adsorbent. That's it. So in this way, you can get the area of the adsorbent. Let us move ahead. So we have 1.68 into 10 to the power 24 molecules of N2. And this many molecules forms the monolayer, which covers the entire surface of 1 kg of adsorbent pellet. So you have the adsorbent pellet, and over here you can see the surface of the adsorbent is covered by the adsorbed molecules of N2. And the number of such molecules is 1.68 into 10 to the power 24. So here, for your understanding, I have shown that the entire surface is covered with the entire surface of the adsorbent. It is covered with N2 molecules. The number of these molecules is 1.68 into 10 to the power 24. Okay, so now let us find out the area occupied by one adsorbed N2 molecule. It is given to us. We had denoted it as AN2. It is 0.162 nanometers square. Now the area occupied by 1.68 into 10 to the power 24 molecules of N2 will be AN2 into this number. So let me denote the area as 80, total area. It is 1.68 into 10 to the power 24 into 0.162, and if I have to convert it to meters square, I will have to multiply with 10 to the power minus 80. So it is 1.68 into 10 to the power 24 into 0.16 into 10 to the power minus 18 meters square. So that is 80 comes out to be 27210 meters square. So this is the area that is occupied by 1.68 into 10 to the power 24 molecules of N2, which covers the entire surface area of the adsorbent That means this area, or 1.68 into 10 to the power 24 molecules of N2, covers the entire surface area of adsorbent molecule. Therefore, the area occupied by this many N2 molecules is equal to area of the adsorbent surface. So the meaning is, since 80, this area covers the entire surface of 1 kg of adsorbent pellet, surface area of the pellet is nothing but 80. So surface area of the pellet will be 80 per kg of, that is this area per kg of adsorbent, that is 272,160 meter square per kg, specific surface area, meter square per kg. So in this way, we get the surface area for the pellet. So I hope you have understood how we are getting the surface area of the pellet. If you have any doubts, you please let me know. With this, I end my discussion. Ultimately, we have got the surface area of the pellet. So for this video, I will end my discussion. I hope you must have understood the steps. If you have any doubts, you please mention them in the comment section. In my next video, I will discuss the same numerical, but I will be using the BET adsorption isotherm to get the surface area of the pellet. So for now, let me end my discussion. Thanks for watching my video. Do subscribe to my channel. Tell your friends to subscribe to it. Hit the bell icon so that you will be notified as soon as I upload any new video on my YouTube channel. In my next video, I will be discussing the numerical, how to get the surface area of the adsorbent by using BET adsorption isotherm. For now, have a nice day. Bye bye, and hope to see you soon in my next video.